In this video, we're going to talk about why it's important to specify power supplies with power factor correction. So from time to time, we hear this term power factor correction, but what does it really mean? Well, what power factor correction means is that we're going to correct the amount of input current that we're going to draw from the AC grid. In a typical power supply design, the power supply doesn't pull current in a very effective manner. Instead, a power supply pulls current by pulling abruptly the current for every AC sine wave cycle. And what a power supply with power factor correction does is it enables us to pull current in a much more gradual way. And what that does is it maximizes the efficiency of what we're pulling from the grid current-wise. What typically happens when we pull the current so abruptly is the power supply utility will actually charge us for that extra power. Even though we're not using the total power, that extra power that we're drawing will be charged. In addition to that, the AC grid that we're using will not be efficiently used, and we'll end up having to size the grid and size the AC system with more wire. We're going to demonstrate in this setup here how power factor is measured and how it's also related to the amount of load we're putting on the power supply. So this is a 3,000 watt power supply, and we're currently going to load it with roughly 300 watts, or about 10%. And when we do that, you'll notice that the power supply power factor correction right now at a 210 volt input line is around 0.89%. This is typical for a lightly loaded power supply. Now, power supplies tend to have higher power factor correction when you load them above 50 to 60% of its load, which is typically where you would size the power supply to work anyway. And that would ensure that we will have a much more efficient use of the AC grid because we're pulling the power and the current in a more gradual way, kind of simulating how an AC sine wave would be coming into the power supply.